I thought I would finish up this section by taking a huge step back, and as we've learned a bunch of ML already, think about, is this the important stuff? Is this how you learn a programming language? And so I want to focus for just a minute on what does it take to learn a programming language, and which part of that are we focusing on in this course. So I like to think of it in terms of 5 different things. If you want to learn a programming language and make yourself a better programmer, you need to know the syntax. How do you write the language constructs? If you don't know the syntax, you're not going to be able to write down programs. I understand that. But you also need to know the semantics. What are the type checking rules and evaluation rules? If you don't know what programs mean, you're just trying to write down different things and hope to get the right answer. That's why we keep focusing on what do these constructs mean, what are the actual rules, so that we can reason about our programs correctly. Something we haven't emphasized quite as much is that you need, so far at least, is you need programming idioms. It's not enough to know that there's an if-then-else expression that works in a certain way. You need to recognize when an if-then-else expression is the right thing to use. We talked a little bit about the idiom of using nested function bindings in order to have private helper functions that couldn't be used somewhere else. That's different than just the semantics of let expressions and function bindings. It's about recognizing typical patterns of use for certain features. And then there's these other 2, libraries and tools. So what facilities does the language provide to you that lets you do things you either couldn't do on your own or would have to re-implement a lot of code that somebody else has already provided for you? So an example of a library that usually has to be provided for you is some way to read and write files. If a language doesn't give you that on some level, you're not going to be able to implement it yourself because you need some way to access the file system. On the other hand, libraries for things like data structures, like trees or hash tables or lists, are things that you actually could define on your own. So far in ML, we've used the lists that have been provided to us, but we're going to learn enough features of ML to know that we didn't need that we could have defined our own. And then finally, tools. These are things that language implementations give you to make your job easier. Maybe it's a REPL. Maybe it's something that helps you format your code well. Maybe some of you have used debuggers in other languages. I like to emphasize that tools are not actually part of the language. They're something provided by an implementation of the language or just as a separate tool. And as valuable as they are separate from the language itself. Okay? So these are 5 separate issues. And in practice, if you want to be an effective programmer, you need to get good at all 5 of these things: learning syntax, semantics, idioms, new libraries, and tools. And I would like you to be good about keeping these ideas separate. People often confuse them. Oh man, it's like a pet peeve of mine when someone says, oh, I like the ML language because it has a REPL. There's nothing to do with the ML language that has a REPL. That's a tool that's provided by a particular implementation of the language. And it's good to keep those ideas separate in your head. Okay, so bringing it back to this course focuses a lot on 2 and 3, on the semantics and the idioms. And I want to justify that for you so that you'll continue in the course and understand why we're focusing on that. I tend to not focus on syntax a lot because as much as you have to know it, it's usually not particularly interesting. If you want to study American history, you really need to know the American Civil War ended in 1865, but that is not the interesting part. That's the basic stuff that gets you to actually reason about theories and ideas, and in our case, semantics. The other reason I usually am dismissive towards syntax is that people obsess over subjective preferences. And I am not going to sit here and tell you that this syntax is good and that syntax is bad. I'm not an expert on syntax any more than you are. I do understand semantics, and I want to teach that to you using syntax only as necessary. And as far as libraries and tools, they're really crucial. But you're always going to have to learn new ones. Okay? I'd rather teach you how to think about every programming language. And the fact that we happen to have a REPL for ML or some other language has a debugger, or there's good libraries for writing web programs, is really not our focus. And I truly believe that if you get good at learning semantics and idioms of programming languages, it actually makes you better at learning libraries and tools. Okay? Because it helps you say, oh, how does this library work? What these methods or functions that are being provided to me, what is their semantics and how are they typically used? The same mental skills, intellectual tools you use for learning a language become incredibly valuable for learning libraries. But we're not going to learn libraries. We're going to focus on the languages themselves. And this has the unfortunate effect that it makes the programming languages and the programs we write sometimes seem a little silly. Right? Here we are, we've watched all these videos and we know how to append two lists or take the max number from a list of numbers. I know that real programming doesn't look like that, but I like to use the simple examples so that I can focus on the semantics. And so I ask you not to judge the languages we use by the approach we're taking in the course. If I taught all these same ideas in Java or Python or JavaScript, which I could do, those languages would look silly too. Instead, I want to use these languages because they're the best vehicles for focusing on semantics and idioms. And I assure you that there are ways to take, say, Ruby and use it for web programs, or Racket and use it for real desktop software and so on. And that's just not our focus. Learn the semantics and the idioms in this course and become a better software person and a better computer scientist as a result.